So the next model that we are studying today is a model that is used when your dependent variable is not binomial. It is actually discrete. It's a data where it cannot be in points. So a model a case where dv is discrete. Okay, so discrete means it's a data where it will not go into points. The example include the number of people employed. This data cannot go into points. Number of victims in a terrorist event. So it will not go into points. So any data which is related to demographics is usually discrete because its base is number of humans. So it cannot go into points. So now we are studying a model which is used when the data cannot go into points. So we have studied one distribution in statistics that when the distribution is discrete, we use a distribution that called as Poisson distribution. So since our dependent variable is discrete and it is following a Poisson distribution, so we'll apply Poisson regression. So for that, first of all, we'll load the relevant libraries. And I will load the data and then I'll discuss the nature of the data. So in this data file, you can see it here is that this is name of districts, year, and independent variable. So here independent variable that is relevant is this TERR. This is the number of terrorist victims. So it's since it cannot go into points, so it is following a Poisson distribution. So let me go back. What we'll do is, first of all, I will make its histogram, the ST, and let me copy it. So the data file is df, and if I have to pick one data from the data file, I will use $sign, and I will call it terror. So if I run it, so data is either 0 to 5, 0 to 1. So it is showing me frequency. Okay, so I have to remove some missing values so that it does not, it is data is shortened. So first of all, I am removing missing values from the variables which I am using as independent variable. Then I'm also calculating the some new variables. So the formula to calculate new variable is mutate. So I pick the data file, I pick with the outcome file, I pick the data file. Pipe means joiner. Pipe is a joining command. So first command is pick the data file, join it with mutate command, join it with second mutate command. So when I run it, now I will run the Poisson regression. So POIS is generalized linear model. Terrorism is a function of employment, education, percentage of population, health expenditures as a percentage of population. So it's education expenditures and health expenditures divided by population. So when I run it, it will if I mention it to show the summary. So the interpretation is here. So if there is 1% increase in employment, there is 0.00017 increase in terrorism victims. So health is reducing terrorism, education and employment is increasing terrorism. So there must be some reason, but we are here to learn how to use this model. Now what I'm doing is I need to estimate its wall test or the chi-square test so that I can see the model is valid or not. For that, I will calculate its deviance and degree of freedom. So it will show it here, and then I will show me the p-value. So deviance is 51511, degree of freedom is 175, and p-value is 0. It is 0.35 zeros and 9. So it is significant. You need to remember it. So here it is showing as minus e minus 35. It means 0.35 zeros, so on, and 968. So it is less than 0.05. So it is significant, means overall model is fit. Okay. So what we can do is we can predict the terrorism values, and we can join it with health and education so that we can create a plot. So this is a GG plot. So GG means graphics, grammar of graphics plot, and this is a detailed command. So you can see it here is that if I make it bigger, so let me see how I can interpret. You can notice here is that the line is actually showing us that when there is higher expenditures, there is lower terrorism events. So it is decreasing. Okay, so this is one factor. Second is that you can also notice is that the dots which are a lighter color, like dots shown here, it means higher education. So higher education means lower terrorism. Darker colors are here and some medium colors are here. So it is showing another behavior. So it's because of education. You can draw such diagrams to explain your relationships clearly. Okay, so this is the model that we use when a dependent variable is discrete variable, means it does not go into points. It is a whole number. So and what is the other reason for selecting models? We have already studied. So let me clear it here. So why Poisson? So let me clear one more assumption here. So we use Poisson distribution when there are two reasons. First is that the data is in whole numbers or discrete. Second is the chances for the higher number is decreasing, means the probability of being 1 is bigger than the probability of being 2 is bigger than the probability of being 3. So this is the terrorism event. So higher number of victims is less likely than the lower number of victims. So this these two properties, 1 and 2, since this exists here, that's why we use the Poisson distribution. So how I came to know that the likelihood is falling. So I've shown the histogram here. If I run the histogram again, you can see that the higher number, the less frequency is there. So the less chances that there will be a bigger number. That's why I used a Poisson distribution. So here you can see that the line of frequency distribution is falling like this. Okay, so then it is going to zero, and it is going to zero very fast. So that's why I used Poisson distribution. Hope this is clear for you.